Everyone doing today? Enjoying the conference? Any interesting talks people have seen today? Couples? What do you think of the keynote this morning? Anyone might get a chance to catch that? Mark's a great speaker, isn't he? So I'm here today to start to take you guys through our Kubeflow as a service product. Quick show of hands in the room who's familiar with Kubeflow as a product. I like that, I can work with that. I'm guessing, has anyone used Civo's Kubeflow offering before? Great, we can start from scratch. So we'll take this to kind of a common level of understanding for everyone. So regardless of your level of understanding from machine learning, Kubernetes ML infrastructure, or even things like generative AI, we'll start to break some of these things down, show you how you can deploy them. Our machine learning platform, we try and put as open as possible. So to put it really simply, the entry point for our end-to-end machine learning platform starts at $250 and it launches relatively quickly. So we're looking at how we can start to get these tools into the hands of like small businesses and startups, but scale it up into the larger degree of it. The most important thing to take away is it's all open source. So if you see machine learning projects on GitHub and you want to start leveraging them and using them in a low-cost way, this is the right workshop to be in. I'm joined today by Rishit. Rishit, give us a wave. There you go. Rishit is a ML research engineer at Civo. I myself am the Chief Innovation Officer, so I joined Civo about a year ago to start to put together some of our machine learning offering. Before this, I helped Amazon put together a lot of the certification, planning and product for SageMaker, and I spent about 8 or 9 years building machine learning products for pharmaceutical companies. So I've done the length of the life cycle, and I'm really passionate about making sure that people can grab a hold of new concepts like machine learning and start to apply them, and also remove some of this esoteric, you have to be this tool to ride with machine learning products. If you're interested in coding along today, if you go to this URL and sign up, it will waive the need for a credit card on civo.com, and you'll be able to launch a Kubeflow cluster. I recommend you do that in New York City, and I recommend you spin up a medium Kubeflow cluster. Do that as soon as possible, just because it takes about 10 minutes for it to get sped up. If you're not, you're very free to do this afterwards, and we'll get these slides put into the GitHub repo for you so you can do it at home. And a little bit of overview of what we'll do today is we'll give you guys what is Civo Kubeflow as a service. We'll jump into a little bit about what the Kubeflow CNCF project is. We'll talk a little bit about Llama 2 and Kserve, which is the inference framework that we're using to run the model. And then towards the end of that, we'll look at LangChain and actually how you can use these Llama 2 models as a direct drop-in replacement for ChatGPT. So if you're interested in saving money on your ChatGPT bill, this is a really good meeting to be in. And most importantly, any of these frameworks we're going to show you today can be reused for like all these new models that come out. Things like Mixtral, things like Falcon can be put into this framework and used as well. So with the end of it, we'll get a bit hands-on, and hopefully you'll get a really strong understanding of Kubeflow and how it can be used in machine learning workloads. You get an understanding of open source large language models. And then towards the end of the workshop, we'll run a very simple RAG over those models using some very simple data. So you'll get yourself jumped in. So everyone should be able to use a little bit of the LLM framework and go home and say that they can start building in the large language model ecosystem. So to give you a bit of an introduction, we didn't want to build another machine learning platform that forced you to use proprietary technology. Pretty much every machine learning platform that currently exists has its own standard, its own way of learning, and typically what you'll do is you'll implement your machine learning product into an existing way of working, where if you wanted to leave, you unimplement and re-implement elsewhere. What we're really passionate about with Civo is actually breaking down some of those proprietary barriers and letting you use open source technology and building software the way you would like. We're super proud of the low entry point. Actually, $250 a month is about 10 times cheaper than the other hyperscalers offering. And we think that's really important because if you're a small startup and you want to get involved on a machine learning platform, we think $25,000 is a really expensive first cost to stomach. At the moment, we've got a full range of powerful CPU offerings, but in the very short term, we're looking at how we can get GPUs involved in that. All of the deployment you'll see today is one click. You spin up a Kubeflow cluster inside the environment and everything you need to go end to end with machine learning will be there. Inference, training frameworks, notebooks, etc. And I think most importantly, there's no infrastructure or machine learning experience required. If you have those things, you can scale further and effectively build wider, but we don't want to prevent anyone from being able to access some of these new technologies. And I saw a couple of hands like this earlier with Kubeflow. So if anyone knows the existing architecture, Kubeflow is an ensemble of open source machine learning tools and frameworks. There's experiment management, end-to-end pipelines for integration, different things like training frameworks, hyperparameter optimization, and things like neural architecture traversal. But today, to get you guys started, we're going to be talking about running a notebook, using that as an IDE as a service, and serving a model inside of Kubeflow. And the reason why that's really important is things like the model serving gives you serverless scale up and down to 0 models out of the box. This means you can deploy 5 or 6 models and not have to expand your compute offering to be able to support that. And then notebooks are also the cornerstone of this rapid application development that is really critical to machine learning. If you've heard people talk about this experiment concept with machine learning, you will try, fail a lot, find a working solution, and then work on how you get that into production. And to give you a little bit of an idea about what this will look like, is inside Civo Kubeflow, we'll be using 2 products, Kubeflow notebooks, where we'll be launching either a VS Code or a Jupyter notebook. Feel free to express your preference here. And then what we'll do is we'll launch Llama 2 inside a Kserve container, which will give you a way of being able to get started. A lot of this is reproducible for home as well. All of the code's on GitHub. There's a couple of examples, I think, as well, Rishit, for models like Falcon 2 on there as well, with different quantization options. So a couple of things for you to play with as well if you take this home. And towards the end of the workshop, we'll be using LangChain, which is an RAG. You use that to augment what you're doing with an LLM to effectively add a database that it can reference to be able to increase the accuracy of the results it's returning. There's been a couple of talks actually over Navigate about reducing LLM hallucination using RAGs, so I think this fits in with some of the trending conversations we're having today. So anyone who wants to get involved, come pull this GitHub repo, get involved. You're very free to do it later as well and just follow along. Rishit here is going to start coding as we get through, break down the code and start to show you how it all goes. As I mentioned, all these artifacts are available for afterwards. Rishit, do you want to start to give us an overview of the code base?
Sure. So, okay, let's start by talking about exactly what we want to do. We already have a trained model. We are not talking about any of the problems before this. All we want to do for this workshop is you already have a trained model, you already have some weights. You just want to efficiently put it out, make an API out of it so people can use it or you can use it. That's the goal of this. Any of the problems before that, you can do those with Kubeflow, you can do those with Kubeflow as a service on Civo, but today we'll be talking about this. And so this will be the main part that we talk about, and then later we'll see that this is just like pretty much all APIs that you get for LLMs out there. So you can just drop in or make it work with LangChain or any of these other frameworks that have been built around prompting LLMs or doing some functionality around LLMs. So that is mainly just to show you that it's the same API you have been using probably through OpenAI, Cohere, or any of these LLM companies. Great. So let's get started. So this is the okay. So we have I believe you might have taken a look at the GitHub repository linked over here, and just to start out, we have this Docker file that packs up everything for us, but and most of the things exist in something called main.py. So let's start by taking a look at that. So another thing I've done is, at least for this example, you have, I'll say that you want to run all of this example on a CPU. So you want to run inference on a CPU. There's GPUs coming soon in Civo Kubeflow as a service, So you can do it with GPUs as well. Today we'll entirely focus our efforts towards running models on CPUs. So what we'll also do is choose a quantized model, and all that allows you to do is without going into much of the depth of how quantization works, all that allows you to do is simply put, make the models more CPU friendly and a bit faster to run on CPUs. So particularly what we do is use the Q4 quantization, so that's 4 bits quantization, and that's not really 4 bits. Most of the weights are 4 bits, but then you have things like the activation layers which are not 4 bits. So if you don't know about that, that's not a problem. Today we want to run inference on this. But so while we say Q4, we say what we actually mean is, well, most of the weights are 4 bits. Great. So what I'll do is I'll use GGML, and GGML is also another framework that allows you to do inference with specialized instruction sets. So for example, I'll particularly use AVX instruction set. What the AVX instruction set allows me to do is, all of this is running vectorized code. So what do you mean by vectorized code? If you have just been in software, vectorized code is a way of saying that you hate for loops and while loops and all of these loops. But what you essentially want to do is just have multiple batches of data, or just have multiple batches of inputs that you have, and run the instruction once throughout everything. So let's say if you want to do a simple multiplication, you probably take all of your inputs to do multiplication, make a matrix out of it, and do matrix multiplication. And that's a lot more faster than doing each of these individual multiplications in a for loop. So we want to do things in a vectorized way. Pretty much all machine learning you see out there is deployed in a vectorized way, trained in a vectorized way. Most of the frameworks do this under the hood for you. If you have seen PyTorch or TensorFlow, they do this under the hood for you. And that's why if you're writing a PyTorch training loop, you shouldn't use for loops in it. So that's a bit about vectorization. What AVX allows you to do is something called, so the reason vectorization is so fast is because of SIMD, or single instruction multiple data. So what AVX allows you to do is, it's this instruction set so that your processor can run all of these SIMD instructions and make use of the speed up by vectorization. So what I say is, I want to use this AVX instruction set so my processor can make use of the acceleration I get by vectorization. Great. So that's what I say. And this is a part to the weights I have. You don't see the weights here, but if you go into the Docker file, it actually installs the weights. So when you actually make a container image out of this, you will have the weights here to do the inference. It just does a wget to this Hugging Face URL that allows you to get the Llama 2 weights. So I give it the part to weights. I tell it a specialized instruction set that I want to use, and then I have GPU layers and threads. Usually for 7 billion parameter models, I would suggest using 110 GPU layers, especially for Llama 2. I also say I want to use 8 CPU threads, and all of this is pretty much changeable as you want. I also have another thing that says context length. So a higher context length is usually requires quadratic increase in memory. What the context length means is, especially if you have used all of these LLM interfaces, you first enter a message, you get some response, and let's say you enter a message once more. The LLM knows that, oh, this is what we were talking about in the previous message, right? It has some information from the messages that you did. And this is pretty much true for most of these popular LLM interfaces that you have seen, even OpenAI's LLM interfaces. So the way this happens is because everything you have in the input is essentially your context that the LLM has. So all of this is stored inside the context length that you can use. So what we mean when we say 4096 here is 4096 tokens. So I talk a bit about tokens, and well, what a token essentially is you have words in sentences and words in all the prompts that you give and words in whatever you get out. But what people found out very early on is these are not efficient ways of representing language, because you have things like, let's say, run and running. This pretty much mean the same word or a different word, or you have two words which are very similar in meaning but have a very different word to them. So what's a nicer way to do that is learn tokens from all of these. And what tokens allow you to do is just have all of your input tokenized first, and what that will do is convert it all to numbers and on an average convert around 1 to 2, usually 1.3 to 1.5 words into one token. And so that's what the context length is represented at. So when I say 4096, I mean 4096 tokens, not words or anything else.
Is it worth summarizing a little bit there? So what we're trying to create here is obviously a container. That container, we're pulling the model directly from Hugging Face. I think pretty much everyone in the room is aware Hugging Face is the place where you can store models. What we're doing after we take that model from Hugging Face is then quantizing it, particularly for these CPU instructions using AVX. And the reason why that's really important is instead of running it in a single thread, you can actually horizontally scale that process across many of the CPU cores and many of the CPU threads to be able to make it faster. I think the other part about why that's important is things like context length involve having more data across there. And I think a good example of where that is things like when you're using ChatGPT, your existing message history is given inside that context length. So being able to include the important context towards an LLM is actually a really important attribute towards the accuracy. Anyone have any questions before we go any further? After you, Rishit.
Okay, so that's what we do, and all of these APIs that we see auto model for our causal language models are pretty much GGML APIs. So GGML is a framework to run tensor operations very easily, and it's pretty optimized for CPUs. So that's why we mainly use this. Now I have some API serving code. So before you see quite a lot of API serving code, which probably doesn't come out right out of the box for you, let's do one thing. Let's go to OpenAI APIs, and they have some pretty nice documentation. So let's take a look at API reference. And I know that there are quite a few LLM models that pretty much follow this documentation in terms of how to serve models. So we'll try to do pretty much the same as well. So let's see the chart options, and I see that there are quite a few chart endpoints. It says I have a chart endpoint called V1 chart completions. Interesting. So, and what this does is creates a model response for the given chart conversation, and then I have some other endpoints as well. Let's see the other endpoints. Okay, so never mind. So you see one of these endpoints here. You usually, if you just go through the documentation, you'll also have a few other endpoints that you particularly want to support. So we'll try to do the same thing. You also have the V1 completions endpoint. So what the V1 chart completions endpoint usually for most of these LLMs does is you have an LLM that is that is focused on getting instructions from your messages. So you can probably instruct it to do something or ask it a question and the response it gives you is an answer to that question. But this is not how LLMs are trained under the hood. So under the hood, when you are training, what happens is you train your LLM to say, oh, this is some text I already have, and I want you to predict what the next token is. So it predicts the next token, and then it predicts another next token, and so on. That's how it generates all this. So what it's essentially doing as its training objective is completion. It's not trying to answer your question or anything. It's trying to complete whatever you wrote. And this way of training is often called mass language modeling. That might be pretty popular around internet right now. So that is how it is trained. So what the V1 completions endpoint, usually what you want to do with the V1 completions endpoint, and you also get this with OpenAI APIs, is that you give it some text and you want it to complete your text, not answer your question. So that is not what you see on chatgpt.com or Cohere or huggingfacechat.com. Well, it's called chat.huggingface.com. So that's not what you see over there, but that's how it is trained. So you also have this endpoint. The other endpoint we have is the chat completions endpoint. And as you would expect, this is essentially what you see on all of these popular LLM interfaces. You give it some instructions, you give it some questions, and it answers those questions. We won't talk about how you get models to do this if they are trained by doing completions. We'll leave that for some other time. But those are two of the endpoints you have. And then you also have the V2 endpoints. This is also something you have with OpenAI endpoints and all of these LLM endpoints. And what the V2 endpoints usually do is some form of concurrency. So you can pretty much run multiple prompts together, and you can also you can run like multiple prompts together. So you can also do that with the V2 set of endpoints. So that's the endpoints we have. And let's start by taking a look at one of these endpoints. And all of these are pretty much similar. So we can start by taking a look at V1 chat completions. So first, what we have is a chat completion request object. And this is actually pretty simple. All this says is I have some message. I have some messages that I'll take, and it also has something called max tokens. So that's how many tokens should it generate as an output? What's the maximum number of tokens? So that's all this object tells us to do. So yeah, so that is the request that we have. We take the messages that we get and just put them into one string. So that is, if you see any interface, so that is the input you give to the interface. It's usually one string. You get out a chat completion request object that has multiple strings in it, and then you probably want to get back to a single string. Then our LLM understands tokens. It doesn't understand words or English. So the first step is to get out tokens. Now with Hugging Face APIs and GGML, it's pretty simple to do this. We already made an LLM object like we talked about earlier. So all I can do is LLM.tokenize, and now the tokens that I get should be a few numbers that represents what the tokens that my input has. Now what I do is call LLM.generate on each of these tokens. So it's taking a few of these tokens and generating outputs for this. So that is essentially what we are trying to do over here. Now I also have some code that allows you to do streaming responses. And what this means is, if you have ever seen any of these popular LLM interfaces, whenever they answer anything, answer to a query, you usually see it streaming, right? You don't see, well, probably in some interfaces you can, but in most interfaces you see like some of it come and then another part come. So all of this you see it in a streaming fashion. So you can also do this with the API, and I also have a method here to do that. This, as you would expect, is an async function. So you can also do this, and this is usually a bit less CPU intensive because because the inputs because the outputs that you get that you get have a very small context length compared to when you run the LLM on the entire text. Great. So we can also stream responses. So that is about the API that we have, and that is all the endpoints that we have right now. So let's see. So let's go to the next part. So now that we have an API constructed, I can also build build an image out of this. I have this Docker file, so all I can do is Docker build, and that will also create an image for me. So let's try to do it right now. I'll just call this Llama 2 ggml and probably give it some tag. So this will start creating the image for me. I'm in the wrong directory, so let's go to the right one first and then call this. So great. I already built it before the talk, so it has everything cached. If you are trying to do this, it will take a few minutes. It won't be as fast as this. I have everything cached. But well, this creates an image for us. So now I can use this image and start doing inference. Great. I can also run this locally and start doing inference. So that is great too. But this is not all that. But this is not all that I want to do for inference. What I also want to do for inference, especially if I'm making an API for any of these LLMs, is use some proper inferencing service that allows me to auto scale as my requests come in. So if I have a lot of requests coming in, you probably should start another container instance that should be serving this model. And if you don't have any requests come in, you should probably scale it down. So these kind of infrastructure problems is exactly what Kubernetes and Kserve handle for you. So Kubernetes allows you to solve most of these infrastructure problems, and Kserve is an abstraction on top of it that allows you to do serverless inferencing. And why I particularly like Kserve, or as it earlier used to be called KF serving, is because it allows you to scale down to 0. So what scale down to 0 essentially means is there will be no container instance running if you have no requests. Yeah, that's why I use Kserve quite a lot if I want to do like serverless inferencing. So that is what we want to do now. So let's try to get this deployed in Kserve and make use of all the benefits of and make use of everything that Kubernetes and Kserve abstract for us. So let's start by, yeah, I have it over here. So this is what the Kubeflow central dashboard looks like. If you haven't created a Kubeflow instance yet, it's pretty easy to do on Civo Kfast, and it's quite a few lines of YAML if you want to try and do it yourself. A few hundreds of objects, each with different versions. So it's nice if you try to install it yourself. I definitely recommend you do it. So I'm using the test cluster over here, the most unique name I could come up with. But essentially, if you want to create a Kfast cluster, all you can do is add in a name, give it a size. As Josh said, you could choose medium, or you could also choose any of these other higher ones. And that's pretty much all to create a Kubeflow cluster. Once you do that, so this takes quite a while. This is deploying quite a few Kubernetes objects and Kubernetes CRDs. So this can take about well, 10 minutes. Yeah, so this can take 10 to 15 minutes to come up online. But once it does come up online, you would see something like this that gives you a dashboard URL. And this is the Kubeflow central dashboard. So that is what I have on my screen right here. And as Josh was saying earlier, this is quite a few tools that work together with each other. What we are particularly interested in right now is endpoints. Endpoints allows you to deploy Kserve. So let's try to do this. So first, let's start by clicking new endpoint, and this asks me for some YAML code. So what is this YAML code that it asked me to do to put in my to get my endpoint online? So what this is expecting is Kserve YAML, and that is pretty akin to Kubernetes YAML if you have written that. So all I'll say, so this is my Kserve YAML, and all I want to do over here is define an inference service and give it give the Kserve endpoint some name. So this is the Kserve YAML I had, which is named Llama 2. That's why you see Llama 2 over here. And then I also have a field called namespace. So the namespace I'm in, the namespace where I'll be running things out of. There are also quite a few namespaces, by the way, that Kubeflow creates for you. But the namespace I'll be running things out of is my-profile. Kubeflow has different namespaces to do to deploy all of these components. So you have all of these components which are essentially just Kubernetes YAMLs under the hood, and some of these are separated into different namespaces. Usually you have a user namespace where you'll run most of the things, and if you try this on Civo Kubeflow as a service, you'll be prompted to give a name for your namespace. So mine is called my-profile, and I say I want to deploy it there. I also have this annotation for Istio, and we won't be talking about why this is necessary today. It might require us going into quite a bit of detail, but you can take a look at the documentation for why we set up this annotation for Civo KFAS. And then I have my container image. So this is not the container image I built right now, right? Well, this is the container image I have in the GitHub repository. So if you just take a look at, well, I'm in the wrong repository. Oh, but also shout out to this repository. This is called Kubeflow examples. This has examples for other kinds of things as well, which we're planning to showcase as well, but not today. So I have a GitHub workflow here. This is pretty simple, and all this does is literally the command I shared with you, docker build. This literally runs the same command, docker build, and this does it as a CI step. So I have my container created and pushed on each commit over here. So this is the container image I will be using. So this is the exact container image I have put in the Kserve YAML. Great. So with that, we have a Kserve YAML ready. And if you see over here, all this requires is 8 CPUs and 32 GB memory, which is quite less for running all of these LLM workloads. But that's because we also quantize the model. This is a 7B model, a 7 billion params model, and we also quantize most of the weights down to 4 bits. So we can run it with these less resources. So I have the Kserve YAML here, and what I do is add that as a new endpoint. So if you are following along, you could just go ahead. If you have this, if you want to change the namespace that you have, and just deploy this YAML. This could take around 5 minutes to get on. It will start by pulling the container, setting up the inference service, downloading the model weights. So that can take around five or so minutes. But once you do that, you have this inference service ready to run, and this also gives me a URL from where I can call my model, and yeah, that's about the inference service that I have. So let's now take a look at running a few examples with this. So Kubeflow notebooks, so I can run my examples over here. And Kubeflow notebooks is pretty straightforward. All this does is whenever you click on create a new notebook, it creates isolated environment for you. And under the hood, what this is doing is this is running in a pod. So you have a new pod created, and your Kubeflow notebook is an isolated development environment that you have. And this is also, let's go into the Kubeflow notebook. But this is also a pretty privileged development environment. So you have access to the Kubernetes resources that Kubeflow creates. So yeah, you can also use those. Let's start by running one of our examples. So all this does right now is, let's run this first. So all this does right now is simply uses the OpenAI client-side libraries. I use the Python client-side library. I give it the base URL, so I'm not using the OpenAI endpoints. So I give it the base URL, and well, where did I get this URL from? That's the URL that endpoints was serving my model on. So this is the URL that endpoints was serving my model on, and I want to use and we had two sets of endpoints, right? We had V1 completions, V1 chart completions, and then the same for V2. So I just say that I want to use the V1 completions. We haven't set up API keys yet, so I just pass in some random API key. You can literally pass in anything you want. And then I use the client.chart.completions from the OpenAI SDK. So what I can do is give it some system prompt. That is what I have over here. I have some system prompt, and I have some user prompt. This is the prompt I give it. And then I have quite a few output settings. You can set this if you wanted to. And this is just to show that our endpoint is pretty akin to all of these LLM serving endpoints you find online, because you can use it with the OpenAI SDK, which has a set format of accepting endpoints. And you could most certainly just do simple curl and get this as well, but it works well with the OpenAI endpoints. So this is what we run right now, and I see this did give me some output. So I haven't set streaming to on right now, so this is giving me outputs in a single chunk. If you had set streaming to on, you would have multiple outputs come in for some of the tokens each. So I do get an output from my API, and I can also see that I have the logs over here, and this is most likely what I ran right now. So that did seem to work. And by the way, if you don't recognize this prompt, this is a smartly crafted prompt from the official chain of thought paper. Pretty interesting paper on how you can get LLMs to do interesting capabilities. So anyways, this prompt is taken directly from the paper. What I can also do is just run it in curl. So this time what I'll do is I'll run the V1 completions endpoint, just to show you that this is different from what we do with chart completions. So we just write chart completions here. So we had stuff like you could enter in a system prompt, enter in a user prompt, and the user prompt is actually a question. So it asks it how many apples did I remain with? Let's think step by step. So this is a question, and the LLM answers that question. But the completions endpoint is different. So in a completions endpoint, all I have is once upon a time. and now it will try to fill up rest of it. So let's see what it comes up with. I haven't, so over here I had set in a few max tokens, so that's how much it could generate. I haven't set in any max tokens here, so it could pretty much generate how many ever tokens it wanted. So this can take a while if it generates a lot of tokens, which I guess it will. So let's wait for a moment, and until then, feel free to try this out yourself or ask Josh and me if you have any questions. Well, it does do that, and if you see, it actually thinks of this as one complete sentence. So your prompt and output seems to be one proper coherent complete sentence. That's what it's trying to do. So that's about the completions endpoint and the chart endpoints. Usually you also have an embeddings endpoint. I haven't made that embeddings endpoint here because at least for today, we are mainly focused on doing inference. Any problems which come before inference, training, fine-tuning, all of that, today we say we don't want to talk about that. So, but if you wanted to do inference on this, you would probably need an embeddings endpoint as well, but we won't talk about that today. So next up, let's take a simple, so now we know that the endpoint works, and I think we are pretty much done with the demo. So that's what we wanted to get out from this. But I also wanted to show that this is pretty similar to all the other LLM endpoints. So you can literally just put and place it into any of these fancy prompt generation or prompt template engines like LangChain, for example, which allows you to, because you need to copy paste prompts and put them in some format. LangChain, at least for this example, LangChain does that part for you pretty well. Usually what you would do if you wanted to be faithful to the definition of retrieval augmented generation or RAG is you would probably do something like Matryoshka attention, which is a popular method for making sure that that model outputs can be properly referenced. However, today we'll take a very simple look at what we want to do, how we want to implement RAG. What all we'll do is exactly what Josh said. We'll have a list of documents. All of those documents will be inside our context. So that might not be the best definition or the best way of implementing RAG, but that is the way you would do it if you hadn't fine-tuned a model or if you hadn't trained a model to explicitly do that. Great, so let's do that. And I'll start out with setting up my model. So I'm using, let me actually restart the kernel and remove all outputs because this gets, I guess, like quite distracting. Yeah, great. So yeah, now I have a fresh kernel. So I'll set in the same base URL, and what I'll also do is I have a few texts or a few documents over here. What I'll do is get the embeddings. So this is where the embeddings endpoint would have come into play. We particularly are not tackling any before inference problems. So what I do is I use another model for getting these embeddings, and all this does for me is creates a space, an embedding space for all of these texts that I have over here. So I can do that, and this might take a while because it will first download the weights for this embedding model, and then it will actually do the embeddings. Great. So now we have the embedding space created, and you can also see this is all the documents that we have. All of these are just single sentence documents for today. And now all of this code is pretty much taken from the LangChain examples. It seemed to be a pretty popular library, and all we'll do is just and all of this is particularly taken exactly from their examples. A brief intuitive overview of what this does is this allows you to put in all these embeddings that you generate for all these 10 documents inside your context length. So the model now thinks that this is ground truth information that you have given the model, and with LangChain you can just put in this prompt template that puts all of these documents inside the context. And once you do that, you can run the same LLM with all of these texts inside its context, and that should give us something that references the set of text that we have. So this is still performing inference, and let's give it a minute or so to perform inference. This is often another thing. You probably should have some GPU to speed up inference. On a CPU, you can get it to perform reasonably well. Get it to get like outputs in 30 seconds or so, but that's about it. So yeah, we actually see something about the NBA teams, which is taken from a text as well. So yeah, that's about how you can use an example about doing any of these things that you do with other LLM endpoints, and you could literally drop in replacement, use this endpoint that we created right now. So maybe Josh could go on over the next parts of the talk. I'll switch to that.
There you go. So I think it's quite a lot to summarize there, and I think actually some points to kind of put a finger on. So that's launching an inference service. Think of it as a container that runs your machine learning model wrapped by a web server. Those things can be put into your Kserve, which is inside your Kubeflow. That will scale to 0 when you're not using it. So in the event that you're running a fleet of models or many models, you don't have to worry about what's taking up your RAM. That's really useful if you've got a GPU behind what you're doing, because then you can have a single GPU back very many models. That's something we're really passionate about, because it means that you as a customer can save behind a lot of those GPU utilizations. Other service providers actually would rather have you rent multiple GPUs for multiple models. What we then looked at is how you can use some of the code that Rishit's written to mock an OpenAI endpoint, and you can take existing tools. So anything you see that integrates into ChatGPT or uses the OpenAI API, you can put into Kubeflow and use that as a direct one-to-one replacement. The advantage with this is obviously there's no price per call. There's no limitations you've got in there. And actually what's also really interesting is your data isn't on OpenAI. We've got some other examples we're working on about how to do this on clusters and on instances as well, so you'll be able to get a one-to-one for those types of environments whilst you're on there. And then a very simple example about what we were doing there with retrieval and augmentation, so that if you had data, say for example in a database or an S3 bucket, and you wanted to put that alongside your machine learning model, you can have your endpoint read that information and put it across. Does anyone have any questions? Anyone been following along, need any help?
To your, I guess, overview of the Kubeflow? Yes. And then we're using the GTML model, but GPU architecture for just fine on string transforming, right?
Yeah, absolutely. It's just various different formats. I think actually...
GGUF is the model to replace GTML, I think.
Exactly right, and I think the speed at which these formats are coming out, I think actually a lot of it's being pioneered by Anthony Horowitz, the hedge fund, and Andreessen Horowitz, and yeah, there's actually a really valuable model quantizer right now called the Bloke that's pushing some of the boundaries for some of these pieces. So the thing that's really important is if you see these open source models on places like Hugging Face, you can just drop them directly And then a lot of the closed ecosystem that is OpenAI, you can use these open source models in, and you can see that it's a relatively out-of-the-box experience for what we do in Kubeflow. There's a huge cost saving there if you've got the load high enough, but I think also the thing that we always talk about in Civo is autonomy and mastery over your own workload, to being able to be in control of your own piece. If you compare this to products like AWS Bedrock, you'll probably be shocked that we let you have a lot more control over the underlying infrastructure. You can even specify some of these things and scale them down to 0. Rishit also mentioned one of the other repositories we've got then, which is Kubeflow examples, alongside Kubeflow workshops, where if you wanted to deploy something like Falcon, you're more than welcome to do there. We've got a couple of PRs in the running for things like Mixtral that will probably be there in the next few months as well. And if anyone would like to fork and make a pull request, we'd be really, really appreciative of any of that work. Hopefully we've made large language models, deploying one, using one, a lot less scary and intimidating, is the hope behind it. And I think trying to break down some of these barriers to make them really simple to use. I think what would probably be just worthwhile very quickly is showing you the rest of the tooling and technology you have in Kubeflow. So you can actually see inside here is that your model's managed, your troubleshooting that your SRE would be undertaking is inside here as well. And obviously your logs and configuration, if you're used to working with Kubernetes, then you'll probably be very familiar with lots of these pieces put around. Now, these things all work in tandem. So think of notebooks as your development environment. You want to think about how your endpoint is effectively where you're running these things in like a production type setting that are deployed. So you can have multiple notebooks take advantage of them. Actually, pipelines is a way that you can automate some of the interaction behind these things and start to build that in. And then experiments, I think, is really interesting, is where you can tweak the parameters you're inputting into that to be able to get more efficient results out of it as well. So there's some examples we've been working on with that recently as well. The interesting part is actually large language models and things like fine-tuning have a really large framework around that. In future workshops, we'll probably look at how we can start to do things like store your data in a Civo database or S3 bucket and start to use some of these functionalities to fine-tune large language models. So the only other thing I'd call out is probably some of the artifact storage you can make in here. So you can store things inside Kubeflow. You can, if you also want to use some of the Civo object store, which is substantially cheaper than other providers to store large files in. And actually, if instead of storing this model in Hugging Face, you stored it in something like a Civo object store, you could get 5 gigabits per second just consistently as a minimum to download these models. We think that's really important because actually a lot of these Kserve containers coming up, just downloading these massive model files. And in cases where you've got like a 70 billion parameter Llama, I think it's a 100 gigabyte file. Another important thing I think we discussed there was quantizing for CPU. So actually optimizing the model you're putting on the platform to be able to be most efficient. We talked about AVX being used for that. I alluded at the very beginning, we're talking about how we can GPU accelerate these things. We do have a GPU version of Kubeflow in a private beta, but we're planning on taking that into general availability very, very shortly. I think that's just about everything. Anything else you want to cover, Rishit? I think that's it. Are there any questions to round out on? Anyone have any challenges following the example during the workshop? Cluster. What a... Bring it round if you can, Dave. There you go. David will take care of that for you. Would be the idea. All good. I guess thank you very much for listening, and if anyone would like to stay in the room and kind of follow the example, etc., you'd be more than welcome to. We'll hang around here to answer any of your questions if you just want to have general chats about machine learning on Civo or running LLMs. Thank you very much, guys.